Supercharged Gen 3 Hemi. Do long tube headers work? Stock SRT8. Shorty headers. Long tube headers. Naturally aspirated. How do they all compare?
Hello everybody, I'm Shorty Hdr, and as always, welcome to the channel. Today it's all about Gen 3 Hemi exhaust tests, more specifically long tube headers. How do they compare to the factory Dodge Ram log style cast iron exhaust manifolds? How do long tube headers compare to Shorty headers? And how do long tube headers compare to the SRT8 factory manifolds on a supercharged Hemi? So only one way to find out. Let's check it out. Okay guys, in this video we're taking a look at 3 different long tube header versus stock exhaust manifold comparisons. Starting off with, in this test, the most restrictive of the 3, the Dodge Ram truck exhaust manifolds. We also have the SRT8, then we have some Shorty headers compared to long tube headers, and we even have them on naturally aspirated and supercharged combinations. So everything that you need to know about headers is going to be right here for your Dodge Hemi. So let's take a look at our first test engine, because obviously the test engine is going to have an effect on the eventual results that we get from these combinations. So we'll take a look at our test motor. It was a 5.7 liter. This one started out as a crate Hemi. I borrowed this one from Steve Dulcich. This one actually had some ported 5.7 or early 5.7 heads. It had a 273 comp cam, which was the biggest at the time of their shelf cams. I'll go ahead and put the specs up here on the comp cam. You can take a look at the lift, take a look at the duration, and I'll also, obviously, as always, include the lobe separation angle. This one had, topping the ported heads, was a Mopar Performance single plane intake manifold, a 4-hole 4150 throttle body, kind of looks like a carburetor. We were running with a Holley HP management system. We had injectors in it. And we ran this thing both with long tube headers and with the stock Ram, kind of tight log style stock exhaust manifolds. I'll go ahead and show you a picture of those. And run with our stock exhaust manifolds, this 5-cammed and ported head Hemi, produced 458 horsepower. Peak torque checked in at 377 to 78 foot-pounds of torque. You could see predominantly the reason for this is the short runner intake manifold wants to make lots of power at high RPM. You can see we made peak power all the way out at 7,000, even the stock exhaust manifolds. But long tube headers, and these were hooker headers. We'll go ahead and take a look at our test description on the hooker headers. These are 1 7/8" hookers with collector extensions on them. And you can see that not only did the headers make more power, they made a lot more peak power. Peak power was up to 483 horsepower. Peak torque was also up 402 foot-pounds of torque. But the nice thing about the headers is that they basically added power everywhere. We loaded this down at 3,000 RPM, and it had a good size power gain basically all the way through the curve. This is kind of something that we would expect from long tube headers, especially compared to the very small restrictive log style cast exhaust manifold that we see on the Dodge Ram. Let's see what happens when we compare it to the SRT8 exhaust manifolds. Okay, now let's take a look at the results of another header test comparing Shorty headers to long tube headers. And this was interesting because I've never had Shorty headers actually perform this well. Usually when I run Shorty headers on most other engine families, the Shorty header performs about like a stock exhaust manifold does. The exception would be on the Ram manifold, the 5.7 Ram, the tight log style manifold that we just tested. Shorty headers would be an improvement over that. But normally Shorty headers do as about the same as other stock manifolds when we test them on big block Chevys and small block Chevys and LSs and stuff. But this was an interesting test, and this is why we do testing, because this is how we find things out. So what we did was run our 5.7 test motor. We're going to take a look at the description here. This was a 5.7, or an early 5.7 Hemi. It was equipped with stock early cylinder heads. It had a small camshaft in it that was 550 lift. It was a 210, 216 duration at 50 and 112-degree lobe separation angle. Like the first test, this one also had the Mopar Performance single plane intake manifold on it, the 4150 4-hole throttle body. It had 36-pound injectors, and then we played with timing stuff. And we equipped it first with a set of Shorty headers, and then ran tube extensions, exhaust extensions past the Shorty headers. And here's what happened.
Wah.
Run on that 5.7, it produced 427 horsepower. Peak torque was 385 foot-pounds of torque. Here's what happened when we installed a set of long tube headers. Take a look at our description. I'm pretty sure that these were these long tube headers. I'll go ahead and put the manufacturer. These were 1 7/8" long tube headers. And what we got on the header test was what we normally expect, at least down low, is we got big gains down low. And this is not, a lot of guys think that headers improve the flow, but what they do is they produce a scavenging effect that helps like draw exhaust out and subsequently draw inlet air in. And good improvements down low. So down here at 33 or 3400, torque went from 340 to 362 foot-pounds. The interesting thing is with this Shorty Hdr test is how well the Shorty headers did up top. The long tube headers made 430 horsepower as compared to 426 or 427. So you're looking at 3 or 4 horsepower at the top. Good gains through most of the curve, but it's interesting that we only got that type of gain at the top. But again, this is why we test. And I don't know if this was particular to the small camshaft or the long runner intake manifold or the combination of those two. But we ran this test to find that out. We also ran this test with stack injection. So we ran the Shorty header versus the long tube header with a stack injection. And even though the power was up on both of those, because the stack injection made more than this single plane, or the single plane intake manifold did, we saw this same type of thing. We got good power gains down low and not huge power gains at the top, even with the different induction system. So interesting test on the Shorty header versus the long tube on the Hemi. Now let's jump over to a supercharged header test. Okay, now we're going to take a look at a comparison between the factory 6.1 liter SRT8 exhaust manifolds, which actually are very, very good for a stock exhaust manifold, especially compared to the log style manifolds that they ran on the 5.7 Hemis. So the 6.1 liter SRT8 stock exhaust manifolds work very well, but we're going to compare those to a set of long tube headers, and we're going to compare them to the long tube headers on a KENNE supercharged 6.1 liter, making pretty good power, to see if there's a change in power offered by those stock exhaust manifolds versus your typical long tube headers. So this was a 6.1 liter Hemi and SRT8. It had a forged crank, forged rods, and forged pistons with valve reliefs to allow us to run a camshaft. It had a set of ported 6.1 liter heads, a factory 6.1 head, but they were actually ported. It had the comp 273 cam in it, which was a 547 550 lift, a 224, 228 degree duration, and 114 degree lobe separation angle. We ran this with a Holley HP management system. We had a 3.6 liter KENNE Bell on here. We had 80-pound injectors. It was configured for this test with an 8-inch lower crank pulley and a 4-inch top pulley. We had the KENNE Bell kit comes with an air-to-water intercooler, which we ran dyno water in. We ran a combination of 91 and race gas, mostly race gas in this case, just to make sure that everything was okay. This thing was running a peak of 23 degrees of total timing. And then we ran it first with the stock SRT8 exhaust manifolds and then short extensions on them. We could take a look at that. Here's what happened. We made a peak of 901 horsepower out of 6,500. It was still climbing. We could have kept revving it. And 807 foot-pounds of torque at 5,100 RPM. And in this range, running from 3,500 to 6,500, the boost only changed by about less than 2 pounds, went from 17 pounds to 18.8 pounds with the KENNE Bell supercharger configured the way that I showed you. The KENNE Bell was also equipped with a very large oval blade throttle to make sure that, again, that we didn't have any inlet restrictions, and a big air inlet system. Again, maximize the airflow into the motor so that you can make the maximum power out of the motor, especially on a positive displacement supercharger. So now let's take a look and see what happened when we added long tube headers. We replaced the SRT8 exhaust manifolds, and here's what happened when we added headers. And just as it did on the naturally aspirated stuff, we saw really big gains from these long tube headers. Let's go ahead and take a look. These are 1.75" American racing headers. We had 18-inch collector extensions and no mufflers, basically just extending the collector length, which tends to add some low-speed power. The timing did not change. The airfield did not change. And we basically ran a back-to-back header test on a supercharged combination. Run with the long tube headers, the power output jumped up to 939 horsepower at 6,500. Peak torque was also up to 821 foot-pounds of torque, which shows us, having tested it on 3 different combinations versus the stock exhaust manifold and Shorty headers, and then the SRT8 exhaust manifolds, that long tube headers on a Hemi definitely add power, even on the supercharged combination, because this is a pretty good gain. We also saw during the run that the long tube headers actually reduce the amount of pressure built up by the motor. So we dropped boost by as much as a pound, and oddly enough, we didn't drop that at the top of the RPM range. We dropped it more in the first 2/3 of the RPM range, where we dropped boost. Up near the top, the peak boost was actually very, very similar. So there you have it. If you want to add power to your Hemi, whether it's naturally aspirated or supercharged, headers are a really good idea. I'm Richard Holder. Please make sure to like, share, subscribe, ring the bell, do all that stuff, and I'll keep testing.